Alright guys, grab bag number 7. This is definitely one of the harder ones, so let's see what we can do. A rectangle is to be bounded by the x-axis and the semicircle. What length and width should the rectangle have so the area is a max? So I need to find a formula for the area of a rectangle, and I want a max. Alright, verify the answer. Okay, now you are going to want your graphing calculators for this one. First thing, I need to figure out what the heck is going on in this question. So what I'm going to do is I'm going to start by graphing that so I can see what that semicircle looks like. Now it should look semi-familiar. It's part of the equation of a circle. So 25 minus x squared. When I graph that, I have this semicircle. So let's see if we can figure out what this question is asking us. I'm going to sketch my semicircle. Okay. Now, based on this, if you can look at this, I hope we can figure out that the radius is 5. Therefore, this is the coordinate 0, 5. This is the coordinate 5, 0. And this is the coordinate negative 5, 0. So hopefully that makes sense. Now, I need a rectangle that's bounded by the x-axis and that semicircle. So here's my x-axis, here's the semicircle. I need a rectangle that fits inside of it. So I'm going to sketch something in here. So here's my rectangle, okay? So I have a rectangle that's bounded by, that means it's stuck within, it's trapped within the semicircle and the x-axis. Hopefully that picture makes sense to you. Now, to find the area of a rectangle, I need length times width or base times height. I need to get these values in terms of one variable. Let's stick with x since I'm talking about a graph. X makes sense. Now, if I look at this graph, I have my axes set there. This value right here is the distance to the right of the origin. That is your x coordinate. So does it make sense that the length of the rectangle would be double that? So it's going to be a 2x for the length of the rectangle. Does that make sense to you? That the length here, because it's the same distance to the right as it is to the left. So now I have area is equal to 2x times. Now the width of my rectangle is right here. Well, what is that in terms of a graph? In this case, that comes from my y coordinate. My y coordinate tells me how high I'm going. This is my x coordinate. This is my y coordinate. Well, if my x coordinate is unknown, then I label it x. Well, what is my y coordinate? In this case, my y coordinate is represented by the square root of 25 minus x squared. That is your y coordinate. Therefore, that y coordinate becomes the width or height of the rectangle. Does that make sense? I mean, this is the biggest concept right here. Hopefully you can understand this setup. Now, I have a formula for the area of my rectangle, all in terms of x. Looking at this formula, do I want to try to combine, like trying to multiply these together? Not really. It's going to get really messy. So what I'm going to do, since I have the multiplication of two different terms, I need to use product rule. So here we go. The derivative of area is high d ho plus ho d high. So 2x times the derivative of this. Picture that as 25 minus x squared to the 1/2. 1/2, 25 minus x squared to the negative 1/2, chain rule, times negative 2x. Plus, so we have high d ho plus ho d high. So now I have the square root of 25 minus x squared times 2. Okay? So let's try to clean this up a little bit. A prime is then, let's see here, it's equal to, if I can simplify this a little bit, that and that cancel, so I've got negative 2x squared divided by the square root of 25 minus x squared, and then I have plus 2 square root 25 minus x squared. So there's my derivative. I want to know, when does my derivative equal 0 or d and e? If we we think about this, the derivative will be d and e when the denominator is 0. What's going to make my denominator 0? 5 or negative 5, okay? Now, looking at my picture, does it make sense that it's not going to be an answer? If it were 5, if that were my value of x, then the length of my rectangle would be 10. And if the length of my rectangle were 10, the height would be outside of the semicircle. So the length of my rectangle has to be less than that. It has to be within that distance. So hopefully that makes sense to you. So I don't have to worry about the d and e. Now I'm looking at this equation. I have that, I'm going to set it equal to 0. What I'm going to do is I'm going to take this fraction and add it over to the other side. 2 square root 25 minus x squared is equal to 2x squared divided by square root 25 minus x squared. Now I can cross multiply and solve for x. So I can stick this over 1. So what I end up with, 2x squared is equal to, when I multiply, I get 2 times. Well, when I have a radical times a radical, the same thing's underneath, the radicals cancel. 25 minus x squared. Divide both sides by 2. X squared is equal to 25 minus x squared. Look how nice that is. So now I've got 2x squared is equal to 25. Therefore, x is equal to the square root of 25 divided by 2. Now if I just throw this on my calculator, let's see here. The square root of 25 divided by 2 is equal to 3.536, because we want we want 3 decimal places, AP rules. So now, I am hoping that that is the maximum for this problem. If x is 3.536, then I will maximize the area of the rectangle that's bounded by the semicircle on the x-axis. In order to verify, I know with every other word problem we've used the second derivative test. However, look at your first derivative. Do you want to take the second derivative? No, let's not do that. So what I'm going to do is I'm going to go back to my first derivative test, which is your number line. When does my derivative equal 0? At 3.536. When is my derivative d and e? At 5. We already talked about that. So now I'm going to test a point. So I'm going to test the number 3. If I plug 3 into my first derivative. Now let's see if you remember how to use your vars key. Okay? In y1, I'm going to type in the first derivative. And this is where you have to be careful. So I'm going to do negative 2x squared divided by square root 25 minus x squared plus 2 divided by, 2 times the square root of 25 minus x squared. Okay? So now I've got that all set up. I'm going to quit and go back to my main screen. I'm going to do vars, go over to the right, enter, enter. I'm going to sub in 3. So now I'm plugging 3 into my derivative, and I get a positive answer, so that's positive. Now I'm going to sub in the number 4. So vars, go to the right, enter, enter. I'm going to sub in 4, and I get a negative answer. So that means the derivative is negative. That means I have a sign change, a plus to minus, therefore that is a maximum. Now you have to remember, we were asked to find the length and width, the dimensions of the rectangle. If you recall, we said at the beginning, the length is equal to 2x. Therefore the length is equal to 2 times the square root of 25 over 2, which is actually 7.071. That's a calculator question, guys. Okay? And we said that the width is equal to the square root of 25 minus x squared. Therefore, the width is equal to, if I sub that value for x, what we found, sub that in here, what you end up with, 3.536. So those are your answers for the length and the width of our rectangle. Well done.